Hi guys, welcome back to the shop. Hey, today I'm going to get on the HS1 crankshaft rebuild, and I'm going to go through it kind of in compartments. We're going to build each individual crankshaft, and then of course we're going to put it all together. And at some point in there we've got to put the labor seal in and make sure the shims get in there and the bearings installed and all that. So let me get you overhead here. I'll show you what I've got and what I'm going to use, and we'll get started on it. Okay guys, I've got everything cleaned up here, measured up, and I think I'm ready to start the build on this. I'm sure I'll get sidetracked somewhere along the way, but we're going to get started on it anyway. As you can see, I've got all the halves cleaned up. I put them, I did them on a wire brush just to clean everything up. That way I wouldn't have any grit or anything that I had to deal with, and then washed them up with soap and water. And the same with all the components that I'm reusing. Now, I decided to go ahead and use the Yamaha rods that were out of my spare crank. There's just absolutely nothing wrong with them. And I was able to find the shims, which were OEM Yamaha, the bearings, OEM Yamaha, and the pins, also OEM Yamaha. So we should not have any problems here. This is everything that you would have used anyway. And I've had a lot of the 125 and 175 Enduros that they don't need rods. They just, everything's in good shape. You put a new bearing in it and pin, and on your way for another, 50 years. So I don't have any trouble thinking about what I'm doing. It really seems reasonable to me. I do have a set of aftermarket rods, but I think I'm just going to save them. I've got a lot of engines running around here that can use those, because the RD125, I believe the AS1C, YASC, they all use it too. There's many that do. I think maybe the YL100 is the same, I'm not sure, but there are some components of the 100 that are different. The labor seal is one thing that is. So there are some differences in there. But anyhow, this is what I'm going to do, and I've measured everything up. I've counted the number of rollers here. They're the same as the ones that come out. The only difference I can see, these are within a thousandths of the same thickness. The only thing I can see that's different is the length of the pin. These actually are a 3R1 1168-100, and they are about 50 thousandths shorter. Here's the original, and here's the new one. You can't hardly tell it. You just tell it when you measure it. In thousandths, I've got 1671 on the original, and 167 on the new one. So it's about 50 thousandths. And what I'm going to do is, I've done this before. I've just got 25 thousandths worth of shims here. I think it's about 27. I took a 15 and a 10. About 28 is what I'm getting there. So I'll be laying that in the hole as I install the pin on the first one. And that will be so it won't go quite all the way through. That way it's, we're not going to be super short on the other side. That's the only reason for doing that. But this is the pin they list, so it should be comparable. Now, I was looking through my book here, and I had noticed, you know, when we put these together, we want 43 millimeter minus 10 millimeter for our overall width on a single. Then when we put it together, we want 126 millimeter minus 20 millimeters. Now what you'll see here is this 0.05 millimeter up here at the top. And I'm not sure what they mean by that, so I went to my crankshaft chart, and when you look on here, it's still saying plus 0 and minus 10 and minus 20 plus 0 on the whole, the two put together. So I'm going with that. This is saying, I think they're trying to say plus 0.05 millimeter. But why would it change? I don't see the reason for the change. So I'm just going with the information that I've used in the past. I've always never added a plus to it. I've always gone on the minus side if I had to. That way you know that it's going to fit back in a case and not be bound up or something else. So I've got the measurements that I had coming out, and they were, actually we had one that was just a little bit over, but we're going to try to get as close to this as we can, only with no pluses. So the first thing we'll be doing is we'll take this one here down and we'll go ahead and install a pin in using our shims to keep it from coming all the way through. And then we'll assemble our crank and go ahead and put this put the other half on. Now the half, the mag side, this is the mag side, and this is the labrum seal side. This is, of course, your seal right here. This is where it fits, and it's just a very, I don't know what the difference is, but it does fit through there. And the whole reason is, these slots in the middle are to slow down that movement. But this is normal for one with a labrum seal, with this type. Okay, so that will eventually go in right here, and it goes in with an O-ring, and it'll probably have to be pressed in a little bit. It'll be a easy press, but it'll be a press. And I bought a whole bunch of, now it's a package of 25, I think, yeah, new seals from Granger. I just measured up the one that came out, and this is the one. I'm just not going to buy a 20 or a 50-year-old O-ring and put in there. Have no choice on these. These are probably 50 years old, but they're going to be better than the ones that have a set in them that came out of it. So that I was able to get. These will press in when we get to that point. And we have to remember that we've got a shim on both sides of this. When this goes together, it'll get a shim right there. And same on the other side. And on this, on the magneto side, or the clutch side rather, this is the clutch side here. Actually, this is the side that goes through the labrum seal, like this. And it's pretty much going to be pressed all the way down, I believe is how it works. They say you can't overdo it or underdo it. Well, I suppose you could underdo it, but you'd have the measurement to tell you that it's wrong. But anyway, the two splined pieces are pressed together, just like this. So let me get set up. We'll go down and we'll start our first one. Hey guys, just a little thing here in the front of my video. I had a viewer, James, sent me this that he made, and he's kind of into choppers, but he watches the channel. You know, just a lot of the same stuff you do to a chopper or you do to any other bike. It's just that, you know, how everything's arranged that is different. But he made this himself, and I just think it's as cute as it can be. This is just really neat. So I just wanted to show everybody that, and that's going to be sitting here on the bench somewhere most of the time, I think. So you'll see it somewhere down the way. Thanks, James. This is just cooler than the dickens. Thank you very much. Okay, guys. Thank you very much. Okay, I've got the part that I'm going to push the pin into here. I've already got it lubed up, and I'm going to put a little oil, light oil, on the pin also. And before I stick that in, I'm going to stick my little pile of shims in. Just want to make sure they lay down flat there. And everything should be good there. Got our pin here. Let me move that on down a little bit. And I'll put my aluminum pusher there. I think I went a little far. Try to keep it straight. All right, let's see if it'll push in there. Okay, that should be it. Pretty tight. Yeah, and that's what I was looking for there, just so it's not coming out the other side. I can always push it more if I need to, but that should be okay. Okay, so we need our assembly lube. Now we're looking for 4 to 12 thousandths in our gap here between the one side of the shim and the flywheel half. Okay, so we've got everything here. We'll take our other half over and we'll try to straighten it out and press it on. All right, Now I've got to stick my little shim back under there. So we'll stick it back in there. Or shim pack rather. And I've got it in there with some grease. Real thin grease. There. That way I don't lose it when I try to stick it in there. And we got our oil on there. And in the flywheel half too. Okay, I think I've got this pretty well lined up here. I just tapped it around until I am pretty square on 3 places, so that I believe will work. So we're kind of started, so let's start pushing here and see what happens. And we're after okay, I'm going to take it off and see where we're at there. I just don't want to go too far. Okay guys, I think we're looking pretty good. We're at 43 right there over the pin, and about 42.93, 180 out. And that's probably all we need to do is come in here and wedge a little bit. I'll show you how I do it. I just take a couple wedges like this. It's not a lot. Now 42.96. So that helped a little bit. So I can go ahead and kind of true these up a little bit, but you can see the pin location here is just slightly recessed and just about the same on the other side. So we're definitely clear of our bearing, and I think it's pretty close as far as this way. It was lined up pretty good over there. The rod is in good shape. I believe we were, the real thing is to have that 43 millimeter or just a little bit less. But I think we're pretty close on our dimension. Yep. So we got to do the same thing to the other one now. So first thing I'll do is take the one of these other ones. I guess I'll take this one, and we'll push the pin in using the same shims that I used on the other one. Okay, again, we'll just put a little bit of real light oil in there. Set that up. I'm just putting the same 3 in I had before. Remember, we took one out. And a little bit of light oil on the pan also. Yeah, it looks just about the same there as it did. Got our 3 little shims. Looks about the same as it did on the other one. Kind of rainy and cool today, guys. We've been having a lot more rain than we normally do, which is a good thing. It's been so dry for so many years. So maybe we're back to our normal pattern. That's all I can say. It's probably 55 degrees. I'm to the point where I'm thinking about shutting the door and turning the heat on a little bit, but I want to get this press work done because I have more light with the door open over here. Okay, all the same prep work here. Pretty gooey stuff. All right. Let me get this back over to the press and we'll press this one on. Okay. And a little shim back in there. Put a little grease on it to hold it so I don't lose it as I turn it over. And I've already oiled up the pan. Yep, looks pretty good. So we'll press on with that. Everything looking good here. Okay, that I believe that's okay. Still got it in there, so we'll see what we have. I guess you're just not going to get past that popping. It's just part of the deal. When the pin's going in, I think it's just the friction. It's looking real good. This is the side we just put in. This was the pin where we just seated the pin first. So it's looking pretty good. About the same. Take it over to the bench and see what we got. Okay, let's see what we got on this one. 4295. We're in spec. And 4278, just a little bit narrow there. So we'll wedge this one. I may wedge the other side too a little bit. Okay, 4293, that's within spec. 42, I got 4290 there. Let me whack this one a little bit. This one you got to get around the rod there, so you got to be careful. Yeah, 4296. I think that's good. Okay, let's see what we got now. $42.97. This is 43.02, so a little bit too much. $42.98, $42.96. I think we'll stop there. Looks good. Okay, guys. So we've got our two little crankshafts built up, just like a single cylinder, and I've already taken these over and aligned them. Didn't take too much to get them straight, but I'm going to take you over and show them to you. And at some point we'll put them together. This piece here will go on here, and it's these holes here are going to face forward, the pin to the back, and we'll have a shim on each side of the bearing here like this. And that's how it'll go together, except that these will be 90 degrees apart. 180 degrees apart, I'm sorry. And then our little seal will go onto this, and we can do all that afterwards. Well, so let me get you over there. We'll get it set up in the lathe, and we'll take a peek at what we ended up with. Okay, let's get this first one in. Okay, this is the one I just finished, so that's why it's so close. Okay, we're zeroed out on both of them, and we've got preload on both. I can't see this one move at all. This one is about a half thou. So those turned out really nice. Okay, so let me grab the other one. Get over there. Okay, so we've got basically no movement here, just a little, maybe a fourth of a thousandth, and about 1/1000 here. So it looks pretty good. And again, preload, preload. Okay. Now one thing kind of changed on me, and I had to refer back to my notes. I'll let you know what that is here in just a minute. Okay, we needed to be at 43 plus 0 minus 10. So we were there, 42.94. I think everything's pretty much the same. Actually, I've got 43.01 back here. I'm going to leave it there, even though it's just a tad over. And the other one, $42.91. And 4,300. So we're right there on our width. And the one thing that is different is the book is telling me that we're supposed to have 12 to, or 4 thousandths to 12 thousandths here. And I've got a good tight 18. And the same on this one. And I kept trying to figure out why. You know, I'm right at my width, and that's what I want to be. That's the most important thing. But I can't meet this. And what I did was I referred back to my notes. And I'd written right here, it's supposed to be 4 to 12 thousandths, and they come apart at 18. So that's exactly the same as what they were. So there's, you know, they really specify this width more than anything. So I'm going by that, and with just a little bit more axial play there, I don't think we're going to have any issue. But that's the importance of writing down everything that before you take it apart. That way you know what it was. And if you run into a situation like this. Okay, the next thing that we need to take a look at, or I'm just going to put these together. Actually, I'll go ahead and separate them by 90, or 180, I'm sorry. Okay, that's that's how they're going to go. And I just had an inquisitive mind, and I measured this width right now. This is pushed in as far as I can push it on the splines. And I just measured that up at 43, 48 or so, okay? And when we get done, we're supposed to be at 126 minus 20, 0.20. So that leaves us with about 17.40 millimeters or something like that. So I just kind of wondered, and if I go to 1740, see, that's exactly the width right there. That's the difference between what it is now and what I'm supposed to end up with. So when this thing slides together, it's going all the way up to here, and it's going to seat right there. So at that point, you should have your 126, give or take, or actually take. So that's where we're at now, and we've got to make sure that we get our shims on. Now, one thing that you've got to do is we're going to press this back together, and it says it's going to take quite a bit of pressure, up to 10 tons. And I just want to show you what they're doing here. See, they're showing pressing this one on with a wedge in here like this, and the bottom one in a plate where otherwise it's supported so that it's not going to change anything here. So it's very important that we wedge everything here properly so we don't end up pushing this half down further onto the rod, you know, taking our clearance completely away. So what I'm going to do is I'm going to make a pusher that'll go over this shaft instead of pushing on the shaft, and then I'm going to wedge on both sides like this, so that I'm actually supporting this side too, you know, over by the rod. So there'll be a set of wedges here and a set of wedges over on the other side. So hopefully we won't get any movement. You know, we need to maintain all the alignment and run out that we have, so that when we put them together, we don't double up on everything, because we've got to check it again then. And we're just gonna, I got to set up to make the pusher. I don't have anything quite like it's supposed to, that it will fit it. So that's what we'll do now. Okay, I've got it marked right here for my length. And this is DOM tubing, so it'll certainly take the strain. And I've got to bore it out. I'm just going to take a cut along the outside just to show the dimension, my length. Okay, looks like what we need. Okay, I've got my magneto side on here with the rod facing out. I've got a little grease on here to hold my shim in place, and I know that the holes, the oil holes, go toward the front, so this is how it's going to go. I'm going to heat this bearing up with a heat gun and slip it on there, and then we'll start with the other half. And on that one, I've already got my shim on here greased up. I've got 2 sets of wedges wedged here and here, and we'll be pointing this rod to the back. But first thing we got to do is get our bearing on. We'll just heat this race as hot as we can get it with this heat gun. This should just pop on. Right down on it. Okay, we'll locate this one. We've got our shim on here. Locate this one to 180 degrees to the back. Should be it right there. I've slide it out enough to get the pusher on. Okay, I think that's it. Okay. All right, looks good. And we're at 180. So let's see what we've got. Okay, I've got 2601 here. 26 is what we want. We really don't want to be any over, but I'm not going to worry about a .01. And let's look at 180. 2581. 2581. So that's within the 20. It is 20, .20. And we just want to see what we're... Okay, we got good tight 18 there. So it must have moved on us a little bit. And just a perfect 18 there. So our dimensions are close. So our next step is to go ahead and put it in the lathe between centers and see what our run out is on this one now. Okay, looks like we're off a little bit here. Looks like four thousandths here and 5 over here, and it's at the same time. So this is coming up like this on both ends, just a little bit. So it needs to be either on this one here, either it needs to, this piece here needs to be wedged out, or it needs to be knocked down, probably. And this side, I'm thinking knocked down, because there's no way to wedge it here. Not too bad, I don't think. You know, when you slide something together like that, you don't know how things are going to turn out and what, you know, what else you're going to affect. First thing I'm going to do is take my caliper and this isn't a big for sure thing, but it gives me something to look at. Okay, I'm at about 764 right there. Millimeter, 7.64. So I come back around to closer to the, okay, see that's 720, 731. Let me go back to the other side of the connecting rod. I've got this magnet over here messing with me. Yeah, 783, so it's a little closer right here in the middle. So I think the first thing I want to try, and we're just doing one side at a time. Don't try to do them both. Chances are, if you change one side, you're going to affect the other side anyway. So, and it may be to its detriment, and it may be, you know, better. But this is the one that has the most. So I think what I'll do is try to open this up just a little bit with a wedge. Actually, you know, I don't know whether that's the right thing or not. I think I may need to close it. I'm just going to stick this in here and kind of move it a little. Yeah, see? It's moving this way. It's getting worse if I wedge that. So it probably needs to go in a little bit. Got to try it. Okay. I just whacked that a little bit right here on the outside. And now we're looking at about 4. And this side is closer to 3. So that's doing something for us right there. So I'm going to take and pull that out again and give it another light tap right here. With my brass hammer. Just a little at a time. See how it's going to affect it. Might get worse, you never know. Okay, see that one moved it back a little bit, but we're still at 4. And this one's where it was, about 3.5. So I'm gonna have to look at some other options here. Okay, I've got it down to 4 on this side and 3 on the right. So I'm going to continue doing what I'm doing. I'm spreading this one here. I'm working on this side right now. So I'll spread this one again and see if we come up with anything. Okay. Just been working it right here. Just 180 degrees from the pin there. And just do that and then take it back over and check it again. Took care of a little bit more of it. Okay, we've got about 2 here and 2 here. So what we're doing is working, so we're going to continue to do it until it goes the other way or gets to where we need it to go. And you know, the key here is both of these are going at the same time and they have been for quite a while. So there's just pretty much one thing that needs to be taking place, and that's, you know, I haven't moved this one, and this one, by moving it, moves this one. So just one at a time, one at a time. If it starts going back the wrong way, stop and go back. You know, instead of spreading it, whack it back in just a little bit or whatever. Okay guys, I think I got it. Took me a little longer than normal. We got preload, and I've got about a half thou on this side, and this one is, you can just see it move a little bit. It's not even a half thou. All right, happy with that. Like I say, it took me a lot longer than I normally take on those things, but I don't generally do these twins. You know, it probably took me 5 minutes on each one as a single crankshaft, and then when you put it together, it's just almost like you're starting over again. And you know, this one took me, I don't know, I'm gonna have to say a couple hours. It was, I'd hit it or I'd wedge it and I'd go past. So I'd have to get back to where I was, you know, tap it or whatever to get back, and then remember how hard I hit it, how hard I wedged it, whatever. And it's just a slow process. It just really is. And some of them can be just a pain in the butt. This one was. But the end result is very good. Okay guys, there we go. I've got the seal on. We'll have to fine tune that as we get to it. But this block should go right in there. And then these tentacles go right up like that. So that's how it'll look. And like I say, the runout is just outstanding on it, but it took a long time to get there. I've got $125.91 there, and when I took it apart, it was 192 right there, and over 180 from that. I've got 192, and when I took it apart, oh wait a minute, got 190. 125.90, and that's exactly where it was when I took it apart. These were my figures there. And like I say, it showed 18. I know the book says it's supposed to be between 4 and 12, but it was 18 when I took it apart. And yes, there could have been some wear there. And I measured the thrust washers that came out, and they were within a thousandths of the new ones that I put in. So I don't think there's going to be an issue there, but we ended up with a good tight 18 there. And just a good loose one there. So this one's probably 19 would be my guess. But that's, I think it's going to be just fine. I had at one time, I was just having so much trouble with it. I went ahead and slid the bearings on. I don't know if you noticed that or not. They don't change anything when you're doing the indicator like I was on the lathe. They read exactly the same, whether you have bearings on it or whether you're taking the reading off the shaft. But I took it and put it on a set of E-blocks just to see if it made any difference. I was drawing it, I was kind of looking for what the problem was. And really, my problem was that I was going past my adjustment all the time. I was just being a little rough. These are very small, and I'm used to, the 125 singles or whatever, a lot bigger, and they don't move as easy, I guess. So you got to whack them a little harder. But in this case, that's why I put the bearings on, and I took them back off for the final and everything. But they were reading exactly the same. Okay, guys, there you have it. We've got the crankshaft ready for the Yamaha HS1 90 twin, and I'm still short one piston for first over. That's 0.25 millimeter, and what I've got is I've got two sets of cylinders, and I actually have a set of pistons for half over, 0.50, but I have no rings. So one set of those mics bigger than the other set, so I was going to use the 50 over or half over, whatever, in the bigger set, and use the 25 over in the smaller set. But like I say, I need one piston for first over, and I need a set of rings for second over. So if anybody knows the whereabouts and don't want them themselves, hit me up in the comments section, or send me an email. Let me know where I can find them and how much they are, or just where I can find them, and I'll deal with all the rest of it. But probably the next time we work on this one, we'll be measuring up the cases to see if our crankshaft is going to fit back in there. It should without any problem. The measurements are almost identical to the measurements that came out, so it should fit. But this is a different crankshaft. The light bulb come on. But it should, because the original crank that came out of it we didn't use, and it measured almost identical to this. The two measurements I got, the 125.90 and 125.92, and those should go right back in there. But we want to do it right, so we'll measure them up just so we'll know if we need to change out the shims in there. I think the shims are selective from 0.3 millimeter to 0.8 millimeter, and then of course you can stack them or whatever. But that's what was available. So anyhow, hey, thanks for going along for the ride, and if you would, please hit the subscribe button and the thumbs up, and hit that bell icon so the next time I put a video up, you're the first to get it.